Hello, in this video we're going to be going over some basic programming required to understand the Arduino tutorial sketches. The topics covered in this video will be variable types, comparisons and logical operators, commenting, conditional statements such as the if, else, and switch case, loops, the while and for loop types, and finally at the end we'll briefly cover functions. Shown here on the screen are the Arduino sketch window and the serial output window. I'm using the serial output window here on the left as the output for these various programs so that you can see that the output produced by the sketch is what I'm explaining it should be, and the actual sketch will be shown in the right window. Now for all of these sketches, since I'm using the serial output, I first have to initialize that I'm using serial with the serial begin command, and that 9600 describes the rate at which I'm going to have my Arduino communicate with my computer. I believe the 9600 is the default, and you'll want to include that for most of these. And just to show that my thing will output to the serial window, use a simple serial print command. This is serial print and then have new line. So this should print hello in my serial output window, and wait 10 seconds and do it again, since the main body of a Arduino program loops continuously. Okay, that error was that I had my Arduino plugged in for too long previously. I had to unplug it and then plug it back in. It should now be working. So I've uploaded the program and it prints hello, and then waits 10 seconds, and then we'll print hello again. So, while this is printing hello over and over and over again, we can talk about variable types. The variable types are similar to those used in C programming. In fact, a lot of the Arduino programming is based on C programming. If you're familiar with C programming, then a lot of this is going to seem familiar. So the first variable type is integers. So that's int, and then you declare a variable type, and then you can assign a value to it. Integers hold a positive or negative value between negative 32,768 to positive 32,767. The next variable type is a long. A long is similar to an integer, except it simply has more space available to it. It can hold values from negative 2,147,483,648 to 2,147,483,647. Both of these come with an unsigned form, in which you sacrifice their ability to hold negative numbers in exchange for doubling their capacity on the positive end. The next variable type is float. Now, unlike integers, which can only hold whole numbers, a floating point can hold decimals and fractions. So you use floats when you need to, for whatever reason, hold decimals and fractions. Just know that unlike integers, a floating point is subject to rounding errors and imprecision. Even if you subtract e from itself, for this case where I've said float e, if you say e minus e, that probably won't give you a number that's exactly 0. If you try and check if e minus e is 0, it might return false, that that's not completely 0. So, while you can hold a larger variety of numbers, it is subject to rounding and imprecision. The next is double. In Arduino, a double is just exactly the same as a float. Then Boolean. A Boolean can hold two values, 1 or 0, true or false. Use Boolean variables when you're basically just... Boolean variables are used as flags, yes, no. You use them as logic tests and other things. Next is character. A character variable is like a small int. It holds a single character as an integer between -128 and 127. This character is both a number and a single character represented by that number at the same time. I can use that as that character. I can print that character and it'll show up as the character represented by the number 17, but I can also do things like integer math on that, and it will behave as if it were a number. There's also byte, which is an unsigned character variable. And then string, which automatically creates a string variable for Arduino. So if you want to hold an array of characters, a list of characters, a string essentially, that's how you do that. A string variable, unlike a character variable though, is a set of information. You cannot do math on it anymore the way you could a character variable. And the final variable type is void, which in this case is only used as part of a function declaration, which says, for this function I'm writing, I don't want the function to return anything. I call the function, it does things, it sends nothing back to the main program that called it. And those are all the different variable types you might need to know for these simple programs. Next, because we're going to be doing conditionals and other things, you need to know how to compare various variables to each other and perhaps perform compound operations with those variables. So, if I wanted to check if two of my variables were equal, because the singles equal sign is assignment. So, up here when I say int a equals 5, I'm saying create variable a and set its value to 5. If I were to write down here a equals b, I would not be checking if a equals b. I would instead be taking the value from b and putting it in a if it's possible. If I wanted to check if a was equal to b, then I could say g, my Boolean variable, is a equal to b. The double equal sign is the comparison, is equal to. So I say put in g assign to g is a equal to b. Other ones that are useful are is a less than b, is a greater than b, is a less than or equal to b, is a greater than or equal to b, is a not equal to b, so those are the various comparison operators. And finally, there's some logical operators. So assign to g is a equal to b and is b equal to h. That's the AND logical operator, the two ampersands here. This will assign true to g if both conditions are true. So in this case, if a is equal to b and b is equal to h, then g will be assigned 1 or true. Other logical operator, it's useful in this case, is OR, and that's these two vertical lines here. That operator says if a is equal to b or b is equal to h, then assign true to g. G will be assigned true if either or both is true. And finally, there's the NOT operator, which says invert the value that's already present. So true becomes false and false becomes true. So with all of that various information, we can go back to our simple serial begin and print. In this case, though, we're going to start with looking at a simple conditional in an if statement. So I'm still going to want my program to print hello, just to show what it's doing. And then I'm going to want to check if I've got a variable that equals 1, then I want the program to do something. Now first, I'm going to assign that variable to 1, just so you can see what happens. And now we've got this if statement. If that variable I that I've assigned to 1 is 1, then it should print goodbye immediately after hello before waiting 10 seconds. So let's upload this. If it's not detected in scope. Okay, there I had a slight grammatical error. If was capitalized incorrectly, and I had the parenthesis touching the if. So I put that space in there so that it's now properly checking the conditional, and it doesn't think that that open parenthesis and the stuff contained within is part of if. It thought if was a variable I had defined instead of the keyword defining a conditional statement. So as you can see, it's printing hello followed by goodbye because the variable I told it is 1. If I go back to this initialization and change the value of I to 2, then when I upload this again, it should instead only print hello over and over and over again. And as you can see, it's only printing hello. The if statement is no longer true, so when it checks that condition, it just skips over the lines contained in the if statement. Now, you can also include with your if statements an else statement. What the else statement says is if that if statement is not true, instead do everything that's included in this else statement. So in this case, it's going to check is I equal to 1, and if it is, it's going to print goodbye immediately after hello. If it's not, it's going to print shrug immediately after hello. So since I still haven't changed the value of I back to 1, this should print hello shrug every 10 seconds. And it does. So for these conditional statements, they're basically how you can check a certain value in your program and do one thing if it's a certain value, or something else if it's a different one. And if-else is one type of conditional statement that you might include in your program. The other type is what's called a switch case. Now I'm going to assign I to 1 again, and then I switch I. So for a switch, I am declaring that variable. I'm asking the program to look at the value of that variable and take one of multiple cases depending on what the value is. So case 1, full colon, not semicolon. I want you to print 1. And then the final line for each case statement is going to be break, because that removes you from the switch case structure. If I did not include break after each case, it would instead go down the line and do everything from all the various cases before finally hitting a break or the end of the switch case statement. And just like an if statement's got an else, a switch case has default. For the default, if it's not any of these cases, then instead do everything that's listed under the default case. And there we've got a switch case switching on I. So if I've coded this correctly, it should print 1 over and over and over and over again. So let's see. Unqualified ID. I said 1 equals 1 instead of I equals 1. And I misspelled switch. Incorrect capitalization. Incorrect capitalization. Okay, part of the way I can catch that is if you can see it, you'll notice that they change colors when I move them to the correct capitalization. That can tell you that you've entered an actual keyword instead of just a variable name. So as you can see, it's printing 1, and then it should wait 10 seconds and print 1 again. And it's doing so. Now, I said we'd speak about comments earlier, and now's as good a time as any to talk about comments, and also with comments to sort of show you what I was talking about with needing the break statements included. Now, there's two different ways you can include comments. You can put these 2 slashes in. That says everything on this line is a comment. Don't run it. That's for me, the person reading the program, to say, this is something I, the programmer, want to read, not you, the program. So the program will run nothing on a line that includes those 2 slashes as preliminary. The other way to do comments are these 2 symbols. The slash star star slash. Slash star says, starting here, everything that comes after this is a comment until you hit the terminator, which is star slash. So if I go in and I make all of the breaks except for the one at default a comment, when I upload this again, it should instead print 1, 2, 3 other. Despite the fact that this is case 1, this is still case 1, it's going to print 1, 2, 3 other because I did not break at the end of my case. And instead, it just continued down the line, and it's going to print everything from all of the cases. If I go back and I remove the comment from 2 and upload again, it should print 1, 2, because there's a break statement there telling it to leave the switch case structure. So those are the 2 different ways you can do conditionals, the switch case or the if-else. And the if-else is good for checking a single condition, and sometimes multiple conditions, but mostly checking a condition. Is this true or not? If it is, do this. If not, either do nothing or do something else. The switch case is more useful in, there's multiple things I might want to happen. I've got this. I'm going to assign a different value to this variable depending on which I might want to happen at this time. And then the switch case goes and says, okay, this is a number 3 case. I want you to do this, as opposed to being a number 1 case, in which case you do that instead. So the next type of programming structure that we need to look at is going to be loops. In this case, we're going to start with a while loop. So, correct capitalization, while I is 1. So, this loop says, as long as I is 1, perform the actions listed in this loop. So let's say serial.println loop. And as this is written, this is currently an endless loop. This will print loop with absolutely no delay, just forever. So in order to make sure that the loop breaks, I'm going to create a second variable j, and I'm going to say, as part of this loop, j increases by 1 each loop, and then if j is 3, then assign I 0, otherwise do nothing. So this should print loop 3 times very quickly on separate lines, and then wait 10 seconds and do it again. As you can see, it prints that cluster of 3, and then it's going to wait the 10 seconds, and it's going to print another cluster of 3. And essentially, your Arduino sketch is operating on an infinite loop, like a while loop where the conditions will never be met to end it. A while loop has a secondary form, which is something which could be referred to as a do loop. I instead write do there, and I finish the loop with while I is 1. I need the while to be on the outside of the loop statements. So this should print those 3 loop statements, and visibly this is going to appear to be the same thing. It's going to print those 3 loops and then wait 10 seconds and do it again. However, if I go back and I start I at 0 instead of 1, it should print a single loop and then wait 10 seconds and go back and do it again. And this is unlike a while loop, because this is going to, a do loop runs the contents of the loop once, no matter what, and then checks the condition at the end. If the condition is true at the end, then it goes back to the do and does everything again. A while loop, on the other hand, checks the condition at the start. So if I go back to a while formation for this loop as opposed to a do while formation and upload this, it should appear to do nothing, because all the outputs are placed within a while loop where the initial condition is never true. It hits while I is 0 or while I is 1, and since I is 0, it never does anything in the loop. And the other type of loop, which is going to be a bit similar to this while loop I showed, because I included an internal condition for terminating the loop, is a for loop. And a for loop asks you to set a counting variable, so I'm going to say in this case k. and then a condition under which you want to keep looping. So I'm going to say k is less than 5. And then what you want to do at the end of the loop to this variable k, such that the loop might eventually terminate. So I've written here, for an integer k starting at 0, as long as k remains less than 5, and then this bit here is equivalent to k equals k plus 1. There's actually a few different ways to write that. So k equals k plus 1 can also be written as k plus equals 1. So plus equals, which you can use for some of the other mathematical operators too, says take the previous value and add 1 to it. You can also use things like minus equals or multiply equals or even divide equals, and it says take the previous value and perform this mathematical operator with the value on the right hand side. So if this were minus equals, it would be subtract 1. If it were multiply equals, it would be multiply by 2. Divide equals divide by 2. And finally, for simple incrementing and decrementing, going up or down by 1, you have k plus plus and k minus minus. So for k equals k plus 1, you've got k plus plus. For k equals k minus 1, you've got k minus minus. So for this loop, starting at k is 0, and then going through k is 5, or 4 in this case. When k is 4, it'll be the last time it runs through that loop. So 0, 1, 2, 3, 4. It should do whatever's in the body of the loop 5 times. Serial dot print print new line. So this program should print tick with a space after it, and then wait a second, 5 times for each time it goes through this loop, and then print talk at the end of that and start a new line, and then wait 10 seconds before repeating the program again. Now let's upload it and see what it actually does. Tick, 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 talk. And then it's going to wait 10 seconds. So you use a while loop when you've got something that you're going to want that sort of external condition. You don't know how many times you want this loop to run through. You simply want the loop to run until it's told not to run anymore for whatever reason. So you could tie it to a button where it simply looks every time in that loop, has that button been pressed yet? And if it has, stop looping. Or you can wait until your circuit meets a certain condition, and it just monitors that condition and it loops until it hits that condition. A for loop is for when I want to loop a fixed number of times. So always do this 4 times, or 5 times, or 10 times, or 11 times. A for loop is I know how many times I want to loop. I know how many times I want this to repeat. A while loop is I want to repeat until a certain condition is met. The final topic we're going to cover are functions. And a function is essentially where you write a program within a program. Something that does. You call a function and it performs whatever task is listed in the function and then returns to your main program. So if I were to write a function called math, and I were to say int math int n, that says I want my function math to take a value from the program that it's given, an integer value, n, and I want it to return an integer value itself. And so I'm going to say n is n plus 5 times 2 minus 3. So it should take those values it should add 5 to n, multiply that by 2, and then subtract 3. And then I want the function to return n as its return value. So if I go back up into my main function, and I'm going to say int k is 1, and then I want to serial print k. So I want it to print the value of k, and then I want to assign to k performing my function math of k, and then print on the next line k again. It should print 1, and then 1 plus 5, 6, times 2, 12, minus 3, 9. And then once again have it wait 10 seconds, and then do so again. K is not, that's a capital K, not a lowercase k. Okay, it prints 1 and then 9. So my function takes an input and then gives an output. If I didn't want my function to return anything for whatever reason, I would instead write, say, void here. It would have no return function. And if I wanted it to do the same thing that my original sketch did anyway, I could have it print n as part of the function and then return. And so if I leave this the way it is, I instead just call math of k. This should print 1, 9, 1. Wait 10 seconds and then repeat. And there it goes. So what happens is it prints 1, it calls math of k, and it puts k into n in this math function, this int n. I do this math on n, which results in a 9. It prints the value of n, which is 9, and then this return tells it to go back to my main function. And since the math function isn't returning anything, it just goes back to the main function. And then I'm still telling it to print k again, but because math is no longer outputting a value and I haven't assigned that to k anymore, it's just going to print 1 again before waiting 10 seconds. Now, functions are useful in that if there's something you want your thing to do multiple times or under multiple circumstances, you can put all of that into a function and just call that function instead of rewriting that code every single time you want it to do that particular thing. The other useful thing is that functions break your program into components or modules, and so if I potentially want to do multiple things with a piece of information, like, say, write it on my serial display screen, or send it to a file, or put it on the internet or something, I can write multiple functions that do all those various things and set them so that they take the same inputs and then produce whatever their output is. And so when the time comes, instead of calling math of k, or in this case serial print of k, I would instead do file print of k or web print of k. And it would perform similar actions using the same inputs, but would have different outputs. So functions can allow you to essentially take out a component that does one thing and put in a component that does a similar thing far more easily than trying to dig through your entire code and find out, okay, here's where I start outputting to my serial, so I need to take all of this, remove it, and then replace it with how I output to web or file instead of outputting to serial. Now you simply replace the function that's output to web with output to serial, and there you go. You've replaced part of your program. And for most of these simple programs, yeah, functions are going to be a little bit overkill. They only do one thing, the entire sketch that is, and needing that level of modularity is just a bit absurd. But when you get into bigger and bigger programs where you might be repeating certain bits of code several times, or where you need to be able to switch out things like that, functions suddenly become incredibly helpful.